Software Engineering Radio, episode 95, The New Guardian, with Matt Wall and Erik DoernenBurg. This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast. So welcome listeners to another episode of Software Engineering Radio. This is another one we're recording at OOP 2008. And in this episode we're going to talk to Matt Wall and Erik DoernenBurg about the new Guardian.co.uk website. So this is an episode that doesn't introduce cool new concepts or technologies. It's more like a case study or a real world example of how to use some of the things we've talked about in the podcast before. So welcome Matthew, and we only have one mic, so I'll welcome Erik in a moment. Why don't we start by Matt, I guess, introducing yourself.
Hi, how are you out there? My name's Matthew Wall. I'm the technical architect working at The Guardian for The Guardian's website, guardian.co.uk. And I've been working at The Guardian for coming up to 4 years now. And I specialised in Java and Agile software development.
Okay.
Hi, my name is Erik DoernenBurg. I work as a principal consultant at ThoughtWork. And my role in the project at The Guardian was that of a tech lead from the consultant side, and I collaborated with Matt on the initial architectural vision and the implementation of the first site that would then later on use the same technology to be rolled out across the entire network of the Guardian sites.
Mm-hmm. So why don't we start by having a brief look at what the Guardian is? I guess, obviously some of the audience knows about it, some don't. So why don't you give us an introduction about the domain?
Well, The Guardian has a long history. It's a high-quality British newspaper. There aren't many of those, but we are one of them. And it has very long history. It's around 150 years old. And around 10 years ago, The Guardian, noticed really that there was a lot going on this new thing called the internet. This was a new way to share and exchange ideas, to publish information. And we decided that we wanted to take our newspaper business online, and thus became what we call Guardian Unlimited, or guardian.co.uk, which is the website version of The Guardian. Initially, as you can imagine, in the late 90s, a lot of the work on the website was kind of experimental. Mm-hmm. We used various products and various techniques to get our web presence going, and we were really, really kind of learning how to do it as we went along. And what we ended up with, partially because of the technical work that was done on the original site, and also probably mainly because of the fantastic sort of editorial content that The Guardian produces, was something that was much more successful than certainly any other newspaper in Europe. I think we're the most read online newspaper in Europe. Mm-hmm. And we actually have very high readership in the States. And the product grew and grew and grew. I mean, I think in total we have something around the order of 2.5 million pages of content on our website. So it's quite a big offering. But the original site was very, very much built kind of out of the newspaper mentality. We were basing it in scripting languages from a technical point of view. Yep. Database scripting languages like TCL and Perl were very, very common here at The Guardian. In the early days of the site, and we were essentially assembling web pages together rather like they're assembled in a newspaper. We were thinking about a page which has an article on it and an advert and another piece of content in these kind of grid type arrangements, and assembling the pages like that. And thus we went for quite a number of years. I mean, the site's very, very successful, and it's grown and grown and grown. But now there's this thing come along called Web 2.0. Yeah. I'm not exactly sure what Web 2.0 is. I
guess nobody is.
Yeah.
It's a buzzword.
I haven't read the RFC, and I'm not sure exactly what it is. I think from the Guardian's point of view, Web 2.0 means a few things. It means that the JavaScript now works. It means that people generally have a broadband internet connection. Mm-hmm. It means that people generally have a modern browser, like a Firefox or a IE6 Plus or a Safari or something like that. And it also means that they have an expectation of being able to interact with the internet quite dynamically. So we realised that our old legacy site wasn't really scalable in the Web 2.0 world, and we needed to look at a rebuild of the site, which is kind of where Erik and ThoughtWorks came in to sort of help us along with that initial process. And kind of what we needed to do was, first of all, get a much stronger model of our business and our content. That's very, very important to us. The previous site, as I say, was kind of, I hate to say it, but kind of lashed together. There were lots of scripts and there's not very much of a model in there.
Historically grown hack.
That's a good way of saying it. Yeah. I mean, we had, for example, on our site, it's a podcast that we're doing now, and we actually had, I think we still have the world record for the most downloaded podcast, which is a Ricky Gervais comedy podcast that we hosted. And if you actually look in the R1 code, there's almost no evidence that the site can actually support podcasts. There's no strong model. So we needed a strong model, and we chose a domain-driven design technique.
I guess let's talk about this a little bit later, and let's first maybe focus on the technology stack you've used and why you've used it, and then maybe visit some of the, let's say, design philosophy and maybe somewhat of the process.
Sure.
So before we look at the technology stack, why don't you give us a little bit of an overview, like how many people were involved, how long the project was running, so people have an understanding of what, like the context, how big was the project in that kind?
Sure. I mean, the initial R1 project was developed by a development team of around 10 people over about 9 or 10 years, along with a systems team of a similar sort of size to support it.
That's the old system.
That's the old system. The new system now on our development team, we have in the order of 50 Java developers working in 4 teams. We have business analysis function, QA function, and everything like that. So it's about 90 people, and we're going to be we've been working on it for about a year and a half, and we'll be working for at least another year, I think.
So Erik, I guess why don't you give us a little overview about the technology stack you've decided to use?
When we started looking at this project as an implementation project of a brand new website, in a way, keeping all the good things, the award-winning design and the award-winning editorial content, adding some of the new requirements that we had heard about, that probably plays a little bit into the Web 2.0 space of what people do with tags and relating articles to each other in a much more intuitive and a much more powerful way. We realized very quickly that we needed to come up with a technology that was capable of serving the amount of traffic, the amount of volume that was hitting the site, but at the same time needed to be very, very dynamic. The approach that had been done so far was to actually press the generated HTML content onto a hard drive. So that means you could really pretty much serve as much traffic as Apache would allow you to do.
Because there was no real dynamic creation of pages. It was kind of statically generated.
Yes.
By the way, that's exactly the same way I do my personal website.
Right. I think it was a very common approach, and it worked very well. The key reason, and we'll come back to that later actually, the key reason why we couldn't do this anymore was that there was now so much dynamic content on that page that we couldn't figure out how to decache those pages. There was just no way that we could figure out, if we change that teeny bit of content, which pages need to be regenerated. So we knew we had to come up with a stack that would allow us to serve most of this dynamically. Of course, we started talking about this with The Guardian 2 years ago. Ruby on Rails was on the horizon. We didn't feel comfortable that it would be able to serve that amount of content and serve that much traffic.
Would you be comfortable today, or would you still say it's Ruby Rails probably for the somewhat smaller?
Today, I would probably do a spike. I would not sign away my life right away and say we can definitely do that in Rails.
My feeling too.
So at the time, we decided on Java. One of the big requirements was that this could be deployed on Linux or a Unix operating system, which ruled out some of the other platforms. And we did want what we call an enterprise solution. An enterprise in that context probably just means big. We wanted something that could serve it. And at the same time, I'm a strong believer in open source software. And I think the way that software is developed really, really mimics what people need. There are hardly any features you don't need. And most of the features that you require are there and work very well. So the stack we chose was an entire Java open source stack. Pretty standard, I would say. At present, it is all upgraded to Spring 2, Hibernate 3, and Velocity 1.5. So again, we even shied away from using JSPs, use some open source technology.
So Velocity is used to actually generate dynamically the web pages.
Yes, exactly. It is the templating language.
Template engine, yeah.
And I said we're using Spring 2 and Hibernate 3, and there's a good point in that we actually do make use of the new features. We just didn't upgrade the frameworks. We were one of these projects, and Matt mentioned it early on, it was very agile. So we're not afraid. We do have the tests, and we can actually look forward to getting new versions of those frameworks, which was another benefit of using open source, that you have constant progress. Yeah. And we actually, as I said, we looked forward. The moment Spring 2 came out, we used some of their advanced features.
Such as?
The custom namespaces, for example, and some of the request scope beans. That these are two examples of that. Yeah. And I mean, they actually helped us. We weren't worried. Yeah. And other things that we used, pretty much standard things, JSON, the Yahoo UI toolkit for the editorial tools, that is the administrative website, exactly which the editors use, because they were quite spoiled, I guess, from the old website, and they wanted a really powerful system. And again, there's more content now, and this is one of the things that really sets The Guardian apart, in my opinion, is the quality of the editorial content.
Yeah, so you shouldn't spoil the editors.
We should spoil the editors to write really, really good stories, which we'll bring back. But that was that. I mean, we really try to focus on a few key frameworks and keep the stack very simple, but at the same time, very highly performant. Deployment is in resin. So again, no big, massive application server, just something small that works, that we knew worked. Development is done in Jetty, which means that developers can run the entire stack within seconds on the developer workstations. Yeah.
So how do you do scalability? Is it all stateless? Do you do replication? No. So you have like basically a load balancer that.
Yes, it is absolutely. It's stateless. Yeah. There's no conversation state with the client server. Sometimes there's a little bit, but that's held in the JavaScript, and you can hit any web server. It's just really IP.
And you have the big, massive backend database of which you assume that it never dies, and so on.
It's it's interesting about the database. I mean, obviously the database is where all our content is stored, and we use Oracle as our backend database. We also deploy to 2 physical co-locations. So we have one in London and one in Manchester, with a WAN in between. The Guardian has always tried to get the most out of the least. So, we try, this is part of our using open source. Or we try and get the most out of our software and the most out of our hardware. And there are lots of very, very expensive solutions to sort of make the reliability of the database. Yep. And when you look at those sort of solutions deployed over a WAN, they become very, very expensive.
Right, so the problem is how to keep them in sync.
Exactly. So what we actually do at the moment is we have 2 Oracle nodes in each colos, and we replicate between them, but we have them in an active-passive configuration. Right. So that means we actually have potentially an unreliable database. Right. So we have to, obviously, we have to deal with that, and we also have to deal with that on deployment. I mean, one of the key things that we need to be able to do is change our understanding, change our model, change our database schema. And we release to production every 2 weeks, sometimes more than that. And that will often involve a database schema upgrade. So without the database unreliability problem, there's still maintenance window database outages, so we have to be able to deal with. And we actually have evolved quite a nice system for dealing with that, which is essentially we can fall back and turn the database off and serve the site out of our EH cache.
So I guess we should talk about that at some point.
Yes, we have it's basically standard Hibernate second level cache that we have installed in our Hibernate layer. However, the problem with that is you're going to get popular items out of the EH cache, but you can't really guarantee what's in there. So we've now sort of augmented that with another approach, which we have a feed running in the background, which actually, rather like the legacy system, it actually presses the HTML of the pages to disk at a point in time and does its best to keep them up to date. Mm-hmm. So what we actually do in the event of a database failover or actually a piece of scheduled maintenance is fall back to those pressed copies of the pages.
Which means you cannot do dynamic updates at the time, and maybe some of the interactive features?
It is actually possible to. It depends what state we've gone into, but yeah, if the database is gone, then no, we can't do dynamic updates. But we can at least serve what we've got.
Right, which is probably good enough for people to don't really notice that something bad happened.
Exactly. I mean, it's all part of sort of graceful sort of degradation,
exactly.
and so forth. And we've actually found that as an approach has worked very well. I mean, ideally, when we move to a newer network layout, which will happen maybe next year, we'll be able to look at sort of high availability Oracle, and maybe we'll reduce our dependency on this. But
So at this point in time, you don't do basically a 2PC commit if you change something over both databases. You commit in one, and then you basically have an asynchronous replication to the other one. So,
absolutely. I believe underlying it all is Oracle Flex clone. I believe.
Whatever that is. I'm not that familiar with Oracle. You mentioned before DDD, domain-driven design. So can whoever maybe want to say something about the design philosophy, or whatever you call it. I mean, it's not the process; it's a way of looking at the system.
One of the things that we really wanted to have with our new version of our site was a shared philosophy across both the development team and the editorial team.
Right. Common language.
Common language, exactly. I think the website is becoming much more important to the newspaper, and will continue to do so over the next few years.
Sure. Yeah.
And I think it's very, very important that the editors don't regard the technical work that happens on the website as a black art, as a mystery. I think they should be involved in it. And so when we first looked at building R2, as well as choosing what technology stack you're going to build, which I think is what a lot of people focus on. I think another massive contributor to success is choosing how you're going to build it, what social processes you're going to build it. Because I'm a big believer that, particularly on a large project that involves lots of disparate people, you've got Java developers, you've got front-end CSS, JavaScript developers, you've got editors who write content, you've got commercial people who are trying to sell ads. And in the middle of all those, you've got this big piece of software. And if you don't figure out a way of organizing those people socially around that software, your project won't be as successful.
Right.
So we decided right from the very beginning that we wanted to have a shared understanding of our domain across all these people. So we all went scurried away and read Erik Evans's marvelous book,
sure.
and then came back and decided that domain-driven design seemed the way to go. One of the beautiful things, I think, of the sort of team structure that we've got at the moment is that we have a very strong domain model which defines how content relates to each other, how content relates to tags, and all of this has been designed by the editors.
And how do you actually represent that domain model? Because I thought that's always one of the, I wouldn't say weak points of DDD, but it's one that's rather unspecified, because having it only in the code is not necessarily approachable for the editors. So is there any way, how do you make that tangible?
That's a very good question. I mean, it was actually quite easy at the start of the project because, again, our focus is on simplicity and what is the simplest way of doing it. And it is basically to get the editors and the techies into a room together with a very, very large selection of sheets of paper and file cards and blue tack and felt tip pens, and get the editors to draw along with the techies what they think they want and what is going on. And it's nice and malleable. You can cross things out and rip things up and draw things again. And that process sustained us for the first few months, really, of the development of the project, really while the core of the domain was crystallizing.
Yeah. And there's also probably fewer people involved.
Yes, exactly. Now the domain model is quite sophisticated, and there are a very, very large number of people on the development team. And it does become more difficult. I used to try and keep these paper copies of the domain model up to date, but it's like, I don't know if you know the English phrase, painting the fourth bridge, but it's just a task that never ends.
Yeah.
And, by the time you've got to the end of it, you have to start again. So we've now started looking at, we can extract the domain model from the code using tools like Magic Draw and stuff like that, and at least get a visual representation of it that people can draw on.
So the master is still the code, but you extract basically graphical renderings so non-programmers can relate to it.
Yes, exactly.
Because I was trying to get at how and whether, and if so, how you use any kind of modeling. But I guess you probably don't, because...
I mean, the whole system was produced socially by sitting down with pieces of paper and drawing a diagram and then feeding that into the development process. But often, once it's crystallized, the model kind of evaporates.
Yeah.
And to add to the idea of modeling, I mean, a model isn't necessarily a graphical image.
No, sure.
A model is probably also a mental model that people have in their heads. And one of the development approaches that we used on the Guardian project was Agile Development. We have really small story cards that specify individual features that the system will exhibit later on. And those story cards, of course, use the same language. I mean, that's one of the big features of domain-driven design. You have the ubiquitous language. So that means in the discussions between the technical people
Yes.
and the business analysts, we use the same language.
Yep.
And by that, we are fairly sure that we have the same mental model of the domain in
Sure.
our heads. When something is called an article
Of
or
course.
a tag, etc., that same model is in there. So there is definitely a lot of modeling. The modeling, though, happens probably
Sure.
in the conversation between the different people and is solidified mostly in the story cards.
Mm.
And then the graphical representation is later on just a kind of almost like a feedback loop.
Yeah,
It just
sure.
shows
to
you
verify
what
that you're
we've done.
yeah.
Yeah. And I think one thing that helped us scale as well is the realization. And if you speak to Eric Evans, he's also coming to the same conclusion that sometimes you just break up the domain model into multiple distinct pieces. There's a couple of advantages for doing so. You get better transactionality, you get better caching,
Sure.
and so on. So the idea of having one big, massive domain model
Well.
that has lots of relationships, so in the end would be like one directed graph, is not really proving very practical.
Of
So you
course
just-
not. I mean, that's the whole story about that the business object model has died,
Exactly.
right? And you try to make data structures more or less owned by the, let's say, service that publishes them,
Yes.
all that stuff. So yeah, that's
Yeah.
also important to scale because I mean, if
Yes.
you have to agree on a common structure in a 500 developer enterprise, you're probably lost.
Yeah, I mean, one thing that really helped us with that was the idea of to focus really on the aggregates and aggregate roots and make sure that nobody actually has any permanent references
Yeah.
to anything but aggregate roots, which
Right.
allowed us to make this
Sure.
more modular and made it
Yeah.
feasible for people to
Yeah.
have a better grasp of the domain model without knowing all the detail of each of the
Yeah.
aggregates.
See, if I probably had done that, I would probably have defined a domain-specific language as, for example, a textual DSL that would know about those concepts. So you could actually write programs using those common language terms as first-class citizens. But I don't want to make this. I don't want to get there. That's why I was asking. So, but since you already have the mic, you have another talk here at OOP. It actually was a keynote about simplicity. And I also heard from what you talked about that simplicity was a key driver in building this architecture. So why don't you spend a couple of minutes and elaborate a little bit about what is simple, what is too simple, what is simplistic, how simple should you become?
One thing that we knew from the start in collaborating on this with the Guardian on setting the or creating that initial website was that this would be like even more so than the old website, probably a technology that would live for 10 years.
Mm-hmm.
And we knew already that if we started with something that was complex or very complicated,
Yeah.
it would not scale in the sense of being extensible for the next 10 years.
Mm-hmm.
So at every piece, at every new jar file we introduced, at every new concept we introduced, we asked ourselves, do we really need that?
Mm.
Very often, as architects, Matt and I did sometimes experiment with new ideas, but then rather than just implementing them, we would have two approaches, the existing one and another approach, and would then go to the developers, sit down with them and discuss which ones they found more intuitive and more easy to use, which one they found simpler, and then always go with that.
Mm-hmm.
So we are really trying to actively avoid being clever. And that comes back to what you asked about before. It actually works quite well in English. I mean, there is a difference between something that is simple, which I think is something you strive for. It is a solution that does make sense and it expresses the intent very clearly, the intent of what you want to do with that code.
Yeah.
That is very, very different from being simplistic.
Mm-hmm.
And simplistic, of course, is something that is simple but just isn't fit for purpose.
Right.
So there are some solutions in there, and we can't really explain. It's quite hard to explain without a diagram, but just to give you an idea, we did have to do something with caching, and there a solution that is on the surface probably quite complicated ends up being very simple. The idea here was that when the editorial tools need to update something in the database, we need to kind of figure out which caches we need to flush in the front ends in EH cache.
Yep.
And of course, the simple solution, or on the surface, the simplest solution, is to just have in the editorial tools, whenever they update an object, to actually send messages and make those updates. That didn't work all too well because people had to think about two things, about what they wanted to update in the database and how to send those caching messages. So we used some of the, like I said earlier on, some of the Spring 2 features with request scope beans to inject special objects into those tools so that they could offload the responsibility for decaching into specific classes.
Mm-hmm.
On the surface, of course, you have to understand how that exactly works in Spring 2. You have to understand what a request scope bean is. There's a couple of really, I wouldn't want to say nasty, but non-obvious XML in some of the in the Spring context files.
Yeah.
But again, the solution now is simple in the sense that it expresses the intent very well.
And it's also simple for the person who has to use it over and over again, and you do the complex stuff once in some kind of frameworky thing.
Yes. And I mean, sometimes complex isn't necessarily bad. I mean, if you have a complex problem, it is okay to have complex code. Trying to make that complex code simple will often end up being very simplistic.
Yeah, that's a distinction between essential complexity and accidental complexity.
Exactly.
And you want to avoid the latter.
Exactly. So. I think, in a nutshell, what we were trying to do is we were trying to drive out all accidental complexity from this. And despite what some people say, you can do this in Java. There is still a little bit of accidental complexity. You have to deal to a tiny extent with some of the remnants of J2E, like web.xml, but we really tried even to push that out. Yeah. We only had, I think the web XML file gets touched, I don't know, once every 5 months or so. So there's hardly anything in there that is worth noting. Yeah. So we've actually moved everything into different methodologies and made that use very simple.
Yeah, I mean the whole focus on simplicity has been a key driver in the project and continues to be. It's very, very important to us, but we don't always get it right, and it is a really, really difficult. It really is a really, really difficult balancing act, and you shouldn't be afraid, as Erik was suggesting earlier, to experiment and try 2 or 3 different approaches, and then collapse back on the one that seems to work the best. But there are examples of things where we've avoided complexity that actually in retrospect we probably should have embraced a lot earlier. So the site has to be very, very performant because we're now serving every page dynamically. We have to really, really have a very, very fast site, and it's actually quite complex to compute related content,
So how many hits or whatever the metric is do you have?
We take about 170 million hits a month from 17 million unique users.
Do you know how many per second that is? Just because I'm curious.
I think the peak sort of thing that we've had on a very, very, very heavy news day, like a 9/11 type event or a tube bombing event, we can do something like 70 pages per second per server in the production environment.
How many servers do you have?
We have 8. So it can be quite quick, although the average load is a lot lower than that.
Sure, of course.
The traffic is very spiky. But an example of where we kind of avoided some complexity that maybe we should have embraced was in calculating related content. I've got this article, it's about these things, it's been given these tags. What other content can the system tell me about that is related to this that I might be interested in? And the simple solution we chose was to actually do that in the database. I mean, we had to do some interesting stuff with Oracle materialized views to get those queries to perform. And it does work, but in our performance testing, it always causes a problem. The more complex solution would be to do that in our search engine. We have an enterprise class search engine, and we and now we're starting to realize that actually that probably would have been the better choice. The cost of performance tuning these queries each release is actually probably much greater than the cost of actually biting the bullet and writing the more complex code to get it off into the search engine. So you can't do everything the simplest possible way.
Okay. So let's briefly look at maybe the development process. I guess you did test-driven development because ThoughtWorks was involved.
Absolutely. It was quite a big shock for us when ThoughtWorks came into the building. I must say, it was like a whirlwind going through the place. Everyone looked stunned for a couple of weeks. But if any of you've got a development team out there that you want to convert to Agile, it's well worth getting them in, I must say, because it's a bit of a shock, but they do sort you out. Now we're at the time where, really none of the developers on our team would even consider writing a piece of code without writing a test for it. It's just second nature to everybody, and everybody can see the value of that. The amount of change we can do is phenomenal.
It's safety net effect, right?
Oh, it's incredible, yeah.
So apart from test-driven design or development, whatever the second D means today, what other Agile practices or process paths do you use? Any of the big name process? Do you do XP, or what is it that you're actually doing?
We don't do XP or Scrum or anything like that. Although whenever I read a book on XP or Scrum or talk to anybody that's doing it, it sounds like we're using very similar processes. I kind of worry about giving the process a name, because my key, if I wanted to sum up Agile in a couple of sentences, it would be, what do you want us to do for you by Friday? It's short iterations. Let's get it done. And it's also let's make sure that we've got a process that we can change next week.
Yep.
And I think when you start to name your process and say we're doing Scrum or XP, people can read a book about what Scrum or XP, how it should be done.
Yeah.
And in actual fact, your processes should evolve and change over time.
Yeah.
I mean, one of the key things that we do is we have, say, short iterations, release to production every 2 weeks, test-driven development, and all of our development is done by developers in pairs. That again makes a huge difference in any team with regard to learning and also the quality of code that's produced.
I interviewed Jens Koldewey, or I should say Koldewey. He explicitly mentioned that. Jens Koldewey yesterday about introduction of agile development practices into teams 10 years of experience, and he said the same thing that you said, that the big name processes are not the important thing, and he said the most important thing about introducing an agile process is doing retrospectives and evolving the process over time.
Yeah, I couldn't agree more. I mean, we now have a number of teams. I have 4 agile teams on the project, which is an interesting thing in its own right. But
you've split down the whole 90 people into several sub teams, so you can better handle the agile approach.
Yes, it's.
I guess that's another best practice for
as a single team. 90 people is just it would just be it'd be a nightmare. But each team has a retrospective at the end of each iteration, and recommendations go into the next iteration.
Yeah. One thing that I'm interested in these, let's say, highly scalable web applications is that performance and scalability are obviously important, and you have to do performance and scalability testing, and that also means you have to measure that somehow. So do you do metrics on performance? Do you do profiling? How do you profile a web applications? Can you tell us a little bit about about the tooling and the approach involved there?
Yeah, I mean, absolutely. Performance is really key to us, particularly moving from a rather static architecture like the previous site to a dynamic one. We have an application server and some Java involved in every page. The first key to performance from development is to keep it simple, as we've kind of said, but you still need to validate that you've got there. So one of the first thing that you need to understand is what level of performance you need to achieve, because obviously achieving ever-increasing performance goals and meeting ever-increasing performance goals is expensive. To get the final 10% is often quite an expensive process. So you need to make sure that the performance goals that you've been set are realistic. So the first thing that we have to do is understand how our existing website performs and scales, and what kind of our traffic expectations are. So we have a number of monitoring tools on the website, things like Gomez, things like Hitbox, which are telling us the amount of traffic that's coming into the site, the amount of traffic that's coming into the site on peak days, and we understand our traffic pattern very well. Monday lunchtime is often the busiest period on the site. I suppose everyone coming back to work and not really wanting to do very much and kind of reading the news on the internet. With Friday afternoons also being quite busy, I think everyone's quite tired by then and also doesn't really want to do any work.
Yeah, looking for the weather on the weekend.
Yeah, exactly. But we also have something that maybe many websites don't have, in that we have very unpredictable kind of performance explosions. If you get a horrible news event or a very major news event like 9/11, then both 9/11 and the London bombings, our website actually stayed up. I mean, it was certainly a lot slower than it normally is, but it stayed up. Yeah. So we have to prepare for both of these eventualities. So how we do it is before every release, we put the release candidate that's come out of our build pipeline through a very, very rigorous performance test suite. Initially, we started thinking very simply about this, and we actually used simple open source tools. So we have monitoring tools on all of our application servers. We have Zabbix that can tell us how much CPU load we're doing, how much I/O we're doing, things like that. We're using the standard JStack and JStat things in the Java distribution to tell us what's going on in the JVM. Because we have Oracle underneath everything, we have Oracle Enterprise Manager, which can tell us what's going on in Oracle. And then we have a suite of tests, and essentially we have 2 types of tests. One of them is one of the tests is for a particular type of page or a particular type of request. Give me a feeling for the performance profile. And this type of test is just more to weed out developer mistakes, simple mistakes. If a developer has written a silly Oracle query or a piece of Java that's not very well written, this will spot that very quickly. But that doesn't tell you whether the system as a whole is going to be able to sustain a load in production. So then what we have to do is take a realistic performance test of production load under various levels of load, your average load, your Monday lunchtime load, and then your kind of 9/11 load, and see how the system performs. It's very interesting with our website and our caching strategy and the stateless nature of the website to write a performance test that the application passes without it really being indicative of what's going on in production. So what we do is we each time we run a performance test, we extract the previous week's logs from production, and we convert that into hits requests against our current website. And that's okay for most things because quite often we'll be migrating functionality from the old site into the new site. Yep. So we knew how many hits these pages got in the old site, so we can translate that into hits in the new site. But also, we're also introducing new functionality. That the old site didn't have. So there we have to really make an educated guess as to how often we think that functionality will get hit in production, and add that together into the performance test. The performance test initially we started basically with a suite of JMeter tests, and it was okay when the performance test data was quite small. The performance test is essentially a list of URLs that we need to hit. Right, that's basically all it is. But now we want to get some more complex metrics, so we actually have got a simple homegrown kind of Python suite that can just extract these URLs and run a performance test. The interesting thing is everyone focuses on pages per second for a website. How many pages per second does it do?
Yeah, I was asking that too. Right?
And, as depending on what mode it's in, we'll do about 70 or 80 per application server, up to around 400 per application server if it's in its emergency mode. But that's not the end of the story. You also need to know, from when it's running at that load profile, how busy is your database, how much more load could you take, what's the application doing. Things like JProfile are fantastic tools for seeing inside that sort of stuff. But the suite of tests should also have other metrics. So what's your 99th percentile response time? It doesn't matter how many pages a second you do. If it takes 5 seconds to generate a page, we say that a page must come out the application server in under 0.5 of a second. And it's important to measure these things.
You mentioned the build pipeline. I guess that's another cornerstone of Agile development, I guess. Do you want to maybe say something about that? I guess also ThoughtWorks is who created Cruise Control, right? So you have some background there, I guess.
Yeah, I think you were right in saying that that's actually a cornerstone, especially with a development team of that size.
Right.
I mean, one of the key ideas that Matt alluded to already is pair programming and collective code ownership, which really, really helps not only educate other people of the development team, but also get very, very good consistency on the macro level. So you don't have people working in silos and coming up with different solutions to similar problems. But at the same time, that means you have one code base. You have so many people working on exactly the same code base, and everybody has the liberty, ultimately, to change every piece of code. And that means, of course, if you're implementing multiple stories at the same time and you're checking in quite often, it can happen every now and then that people start making changes that are incompatible. Many of them you can actually weed out by running the test suite on your local developer workstation before you're committing in obvious merge problems and so on. But then there are other more subtle issues that will only surface once that code is actually merged and run in a more server-like environment. Mm-hmm. And that is exactly where continuous integration comes into play. And that is something that, ThoughtWorks certainly has done for about 10 years now. And we, again, like in collaboration with another large client of ThoughtWorks, we created something called Cruise Control, which is, we call it the granddaddy of continuous integration servers. There's a lot of movement in that space at the moment. There's a lot of commercial entrance to that space, which is interesting. So we are using continuous integration servers. And in this case, we actually do use Cruise Control. One thing that we have learned, though, from the past was that, especially with a large team like that, you do need to have very, very quick feedback. So that means if you have, like Matt said, if you have so many people working on the team, you will get commits almost every 10 minutes. The problem is if your test suite runs every 30 minutes or takes 30 minutes to run, that means people are wasting a lot of time waiting to see whether the build is okay. One of the mantras, of course, is if the build is broken, you must not check in, but somebody needs to fix the build first. Yeah. So that thing is a big issue on large agile projects. What we've done in the past, and again did on the Guardian project, was to split that out into what we now call a build pipeline. So rather than having one single continuous integration server, you have multiple of them. So the first continuous integration server only runs the unit tests, which are generally very fast. they should be in the order of 5 minutes or less.
Yeah.
Because 99% of the problems you actually do find in the unit tests.
Yep.
And only if those pass, the build artifact gets copied somewhere else, and then a secondary cruise control server picks that up and runs the automated regression test suite on that, which could be something like Selenium to test some of the more fancy Ajax JavaScript bits, or HTML unit to test whether the pages actually come out as a more integration test. And those tests can take longer, but it's okay because they don't often find problems. The build pipeline in the case of the Guardian project, of course, continues with the performance test. There are some performance tests that needs to be run all the time. And there's, of course, the old adage about parameter optimization, but one thing, it is actually quite helpful if you come in the next morning and there's an automated page that tells you performance in that area has degraded, and because then you know, what did I change yesterday, what could have affected that.
The Eclipse guys also do this, and they have nice graphical diagrams that show which area. And so I think it's not necessarily important to get a system to a certain performance. It's probably more useful to make sure you don't degrade it over time.
Exactly. It's like Matt said, I mean, some of the mistakes, I mean, especially with all the different paradigms that we're mixing on a project like this, it is easy to make mistakes. And to just give you one example, what occurred on that project was, of course, we're doing Java, we're doing domain-driven design, we have a domain model in Java, and people are doing object-oriented programming. So what happened was there was one functionality required for the administrative application to say which tags are unused. So
garbage collection for tags.
Yes, kind of, or just to display them. And of course, I mean, if you think about it from a domain-driven design and object-oriented model point of view, what you do is you write a loop, you iterate over all the tags, and for each tag you say tag.count equals 0. Do you have any articles? Of course, that translates object relational mapping into effectively pulling the entire database into memory.
Big inhale.
And these things you can spot very, very easily with those tests. I mean, that's an obvious example, but there are very many similar examples. So that was, in that case, what we call the build pipeline. And it's almost like stamps. So you create the first part of the pipeline, creates the deliverable, a WAR file in this case. There were no EGBs, so we just have a .war file. That is created and is never changed later on. So that WAR file first gets the stamp of approval of saying unit tested. Then it gets moved into the second stage of the pipeline, which tests the integration test, gets the next stamp, then gets to the performance.
But in some way, it's more a testing pipeline than actually a build pipeline, because building happens only in the first stage.
Yes,
and then you do different levels of heaviness on the various tests.
Exactly.
In different intervals.
Exactly. Yeah. All the building is done initially.
Right.
And it's actually a part of the whole idea that nothing gets changed later.
Yes.
Everything that is configurable is loaded using the property post-processor in Spring from plain text files.
Yeah. Okay, I guess so. We covered the main points. Is there anything else any one of you wants to mention?
I think one of the key things as well, we've described a few of the processes that we're using at the Guardian at the moment. Not all of these processes were processes that we were using on day one of the project. Yeah. A lot of these have evolved as we've made mistakes, as we've learned from them on the course of the process. And I think if you were to interview us in another year or another 2 years, you'd find that we'd still be using most of what we've got now. But I'm sure there'd be loads.
Hopefully something's changed.
Yeah. There'd be loads more that we can tell you. And this is like a key thing. I think anyone working on a large software project or indeed a small one, don't think once you've learned to process it's static. Be prepared to change it. Be prepared for it to evolve with the internet really, and evolve with your team's experience and knowledge.
Okay, then thank you very much for the interview, and I guess have fun with the talk you're going to do about the same topic in a couple of minutes.
Thanks very much. Thanks for having us.
Yeah, thanks, and bye.
Bye. Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and /dot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.